All right, hello everyone, and welcome to our fourth quarter meeting for Interplanetary Initiative, our updates for the year and our last quarterly for the year. I'm Lindy Elkins-Tanton. I'm the Vice President for Interplanetary Initiative here at Arizona State University, and I'm just going to give a brief introduction before we really get rolling. All right, first of all, some housekeeping. Attendees are not seen and are muted by default in the webinar format that we're using. We welcome questions. Please use the Q&A button at the bottom of your screen. If you put the questions in the chat, we probably will not see them. So put them in the Q&A button at the bottom of your screen, please. And at the end, when we're all finished, the fabulous staff will put together the webinar recording and also a survey, and we'll send out to everyone who came today. So thanks so much for coming. All right, here's our agenda. Quick updates from me about some new programs, some announcements, and a wonderful introduction of Katherine Mcconaughey. Then we'll hear from the team that is working most centrally on our technological leadership degree, our undergraduate degree, which is just wrapping up its first year. Very exciting. Then Danny's going to give us updates on the Interplanetary Lab, our gorgeous space, which is designed for space hardware, build, test, and fly with outside partners. And then we'll hear the real point of it all, the project updates. I do not think it's going to take an hour and a half unless we have so many more questions than I'm anticipating. But we're going to have these really, really great updates from our current active pilots. All right, first an announcement. I'm very excited to announce Open Citizen. This ASU's Learning Enterprise, which is the arm of the university dedicated to lifelong learners, and Beagle Learning, which provides end-to-end programs for running real-world learning experiences, and Interplanetary Initiative, the three of us are partnering to create the Open Citizen project. Open Citizen is a program structure in which groups use an open inquiry process to identify local needs or learning topics, research them, and follow through with meaningful action. Participants practice working in small teams that unite many disciplines and develop workforce readiness skills and make positive change in the world, we think. We aim to empower local groups to identify and solve the problems before them, to democratize the scientific process, and create a global network of problem solvers. We are marrying this process with ASU credentialing and the possibility of university credit. Our pilot Open Citizen partners are Michael Littig from the Zuckerberg Institute, the ASU Office of Applied Innovation, Mesa Public Schools, Edmonds College, CSU Fresno, Illinois State, and WSU Tech. We plan to have an in-person Open Citizen gathering this fall where we will practice the process and begin to build a worldwide network of connected Open Citizen teams and people who are really focusing on learner-centered, project-based experiences. So if you're interested in launching an Open Citizen team or learning more about the structure, please contact us. All right, I would love to hand the mic over to Jessica Rousset, who is our Deputy Director, to talk about some plans we have for an online master's for scientists and engineers who are running large projects. Jessica, you need to unmute.
Thank you for that. Hi, everybody. Welcome. I'm Jessica Rousset, Deputy Director at the initiative. It's great to have everyone join us. And as Lindy mentioned, we're indeed in the design stages for an online asynchronous micromasters that is intended to support scientists and engineers who are in charge of large programs or projects. And so the focus for this micromasters is to develop skills in areas such as leadership, team and project management, finance, and communication. And importantly, we really want to design this micromasters to be as impactful and conveniently delivered as possible to busy professionals. So if you are such a scientist or engineer, or you're working towards a leadership role, or perhaps you're an employer or research sponsor that's investing in up-and-coming scientific leaders, we would love to speak with you so we can get a deeper understanding of the specific training needs to be successful in these roles. And I'll provide my contact information in the appropriate place. I don't know if it's the chat or the Q&A, but I'll provide that, and please feel free to reach out. We'd love to hear from you.
Fantastic. I'm really excited about this. All right, and here's another announcement, the announcement of our Space Futures Alliance. XPRIZE and the ASU Interplanetary Initiative are joining forces to create support to launch the Space Futures Alliance, which is a global cross-sector, cross-industry coalition combining the power of collaboration and shared innovation to build a more just and equitable space future. By working together, sharing ideas, identifying areas of need, and offering resources, the Space Futures Alliance will help accelerate promising and vetted solutions to open space for all. XPRIZE will bring their infrastructure, resources, and convening power to facilitate collaboration and launch challenges and competitions. There will be new XPRIZes as a result of this. Promote data collaboratives and common research endeavors to help achieve the objectives of the Alliance. The first step toward promotion of this alliance will begin this summer and through the fall as a part of the soft launch of XPRIZE's Global Visioneering by convening a who's who of space stakeholders to discuss and recommend the next generation of space-related XPRIZes while fundraising for the broader effort of launching the alliance. We are hopeful that we'll gain enough financial support to launch the Space Futures Alliance in early 2022. So these efforts are led by a brain trust chaired by Anusha Ansari, George Whitesides, and myself. And we are joined by Pete Warden, Chris Hadfield, Bob Smith, Jeffrey Mamber, Chris Lewicki, Tori Bruno, Bobby Braun, Iso Young, Wanda Sigur, Yvonne Cagle, and Etosha Cave. So we're very, very excited about this, the Space Futures Alliance. All right, then we want to announce the next Why We Go Interplanetary Exploration Series. This is a partnership between Interplanetary and the Translational Research Institute in Space Health, also known as TRISH, at the Baylor School of Medicine Center for Space Medicine. And so the next one in purple is June 17th, next week. And the topic of this one is sociology. What are human social futures as an interplanetary species? And I'll be moderating the discussion of Timmy Aganabaginti and Natalie Trevino as we talk about what kind of social and legal future we need for our interplanetary species. Finally, my last thing in my introduction, I'm really excited to introduce you all to Katherine Mcconaughey, who is our new Director of Learning at Interplanetary Initiative, and we're so thrilled to have her join the team. And so I am going to turn it over to Katherine, and then I will stop sharing my screen as we go on to the next part of the agenda.
Great. Hello, everyone. My name is Katherine Mcconaughey. It's great to be here. My background is in engineering, education, and learning design. And before joining the team here at II, I was working at the MIT Media Lab, where I helped start up a research initiative that was focused on the future of learning and education, particularly focusing on collaborative and creative educational experiences that supported project-based learning and student-centered learning. And so I'm really excited to bring all that background to this incredible team, and really excited for what lies ahead as we think about creating the problem solvers of the future. So you'll hear a little bit more from me in a bit, but it's great to be here, and thank you.
Thanks so much, Katherine. All right, I'm going to stop my share and we can move on.
Thank you, Lindy, Jessica, and Katherine. I'm not seeing any questions in the Q&A, so that means we can move on to the technological leadership degree.
Welcome, everybody. I am Josh Thompson. I am one of the team members for the technological leadership major, the degree supervisor. And today, Katherine and I will be giving some exciting updates on the program as we conclude our very first official year as a major here at ASU. So like last time, we're going to briefly go through an agenda to let you know about some exciting updates and happenings within the major, some of the current challenges that we face, and looking to the future, some exciting changes that we have coming down the pike, including a brand new staff member or faculty member, excuse me, that we get to introduce to you today as well. So the state of the technological leadership major, our enrollment is holding at about 45 students, which is what we would expect right now. We do expect enrollment for our online program to start to climb as we approach the fall semester. And I'm really excited to announce that we will be engaging in a new updated recruitment approach, utilizing and leveraging our digital assets and the incredible team that we have for the tech leadership degree. So we're really hoping to be able to use the knowledge of our students' success in the last year to target specifically students who will be perfect fits for this program and who can really benefit from this innovative approach to education. Some interesting little tidbits about the major in this last year. About 64% of our technological leadership students are online only. So this is a very heavily online oriented degree. But what's exciting about those online online degrees here at ASU is that we know that our online education breaks down a lot of barriers that traditionally prevent professionals from re-engaging in academics later in life. So we have a lot of incredibly established professionals who are excited to come into our program and learn the skills that they need to advance their careers. And the online modality is one of the incredible tools that they have at their disposal to meet those goals. 14% of our students are coming from partnerships that ASU is building with affiliates across the globe. And so those include our amazing Starbucks academic achievement scholars and our Uber scholars as well. What's nice about these scholars is that with their corporation support, we know they're able to focus a little bit more on academics than other traditional students because they're not as worried about meeting those tuition payments. So this is a really exciting way that we get to engage with professionals. And we think that the corporate partnerships are potentially a real path forward for a lot of our online students. Then finally, we have managed to place about 42% of our eligible students into internships for this summer. I'd like to think that we did a pretty good job with this. We weren't sure what our goals should be, and we did fall a little bit below what we had hoped. But we managed to do this in a time of COVID, in a time of a lot of uncertainty. And so we're really excited that we were able to place so many students. And we have some really incredible opportunities cropping up for the fall for students who are unable to find an internship for this summer. Some of the current challenges that we're facing include, as we've mentioned before, student engagement in a remote working and remote learning environment. Figuring out how to build community during our first official year has been a tremendous challenge. And we've kind of tried a couple of different things to engage students, but really we've been missing the physical presence of a unit home and actual physical presence of each other. So we're really excited that it's looking increasingly like we will be back on campus this fall, where we'll be able to more simply engage with our immersion students and hopefully create new opportunities for engagement for our online students as well. Additionally, we've been facing the challenges we mentioned previously about spreading the word about our new model of learning. This degree really shakes the foundations, or has the potential to shake the foundations, of conventional higher education. And so as a result, it's a challenge to communicate to people why they need this degree, why it's important to them. I think we're getting a lot better at that. And after 1 year of students, we now have a great data set that we can fall back on and kind of understand with whom these messages resonate. But we're still figuring out better ways of leveraging this incredible program and leveraging our media assets to help connect students to this incredible program. And finally, internship placement has been a bit of a challenge. As a nascent program, most corporations are not necessarily looking to build a relationship until we have more of a track record of success with our students. And in the time of COVID, there was a lot of uncertainty. And so we are absolutely welcome to any ideas or opportunities that you may have for interns in your work with your corporations or companies, or just strategies for connecting with students and communicating to them the importance of the internship experience. So feel free to reach out to us with those ideas as well. And like I said, if you're doing cool things and if you'd like internship support, please reach out to us. You can reach us at careers.techleadership@asu.edu. We would love to hear from you about any ideas that you might have, any leads you might have. We would love to put those to use as well. And without any further ado, I will introduce my supervisor, Katherine Mcconaughey.
Thanks, Josh. Great, so I'd love to share with you all a little bit about what's coming up in the future for the tech leadership degree. First off, I'd love for you all to meet our newest IIT member, an instructional professional, Eric Stribling, who I'll hand over to right now to introduce himself.
Hello, my name is Eric Stribling. Prior to coming to ASU, I helped develop and teach in a new mechanical engineering program at one of Central Africa's top medical universities. With their support in 2019, I came to Arizona State to pursue a PhD in global development, focusing on the role of engineering on the development of society, specifically social aspects of engineering designs. And this fall, I will be teaching in the Technological Leadership program's new Makers course. Thank you very much.
Great, thanks so much, Eric. A little bit more about that course that Eric mentioned. It's going to be our newest offering for online students. It's a maker course, so a making pathway called Designing and Making for an Interplanetary Future. It's a course that we're really excited about. It's going to be very unique, hopefully very hands-on and project-based, but we're doing it completely online. So we're very excited to be experimenting in this space. We aim for students to learn mechanical, electrical, computer programming, and the design aspects of technology development, with a particular focus on how technology and engineering have an impact on society. And we're really going to focus on these student-driven creative projects that can help relate space exploration and an inclusive interplanetary future to these maker concepts. We would love any thoughts or ideas that you have about this, or if you're interested in participating or getting involved, please let us know. One more quick exciting course pitch is our fall inquiry for our on-ground students. This semester, we're going to be working with Professor Dave Williams from CC to explore how we can create or improve the future of humans in space as informed by the Star Trek media franchise. So this is going to be a fantastic and exciting course. If you're a student, we'd love to have you join us. If you work with students, we'd love for you to help us get the word out about this course. And I think that's it from us. So thank you so much.
Thank you. There is one question in the chat. Are there any prerequisites for the course that you just mentioned?
There are no prerequisites to enroll in IPI 296. So we would love to have anybody who is interested, or even if you're just curious about our unique pedagogical approach to this inquiry course, I highly recommend the course. It's an incredible time.
And as well for the making course online, I'm not sure which course you were asking about, but I'm pretty sure there won't be any prerequisites required for that one either. Is that right, Josh?
That's correct.
Great, thank you.
There's another question. What are the costs involved? I'm not sure exactly what they're referencing.
If you are curious about the costs involved with enrollment, feel free to reach out to me at josh.thompson@asu.edu, and we can discuss your specific situation and see what options we might have for you.
Perfect. Thank you, Josh. All right, if there's no other questions, let's move on to Danny with the Interplanetary Lab Updates.
All All right, here we go. Hi, everyone. I give you a short review of what the lab is, just to remind you, and then some updates. So the mission of the lab is to kind of be a physical manifestation of the Interplanetary Initiative core values, and so there's a lot of different aspects to it. But in practice, it's becoming something that's basically like a space makerspace, a place to support development of small spacecraft or other kinds of things like that at the university with external partners. So there's a strong learning and teaching component and a strong doing component. Through most of the year, this is our team. So we have a team of 5 students in the lab that have experience ranging from aerospace and astrophysics to electrical engineering and computer engineering, but also lots of interests in other areas too, like various kinds of applications, things that don't necessarily, like for example, teaching and things like that. Specifically like social good applications and things like that. The space itself, it's a physical space. It is in Sun Devil Hall, which used to be Physical Education Building West. So it's in a gym. In fact, it is a renovated part of the gym that used to be the boys' locker room. It's about 6,000 square feet and has been open for about a year. It's a beautiful reimagining of the space. There's just a user space people can hang out with a kitchen and that sort of stuff. So there's lots of room for students to sort of inhabit the place and do things. Lots of reconfigurable space. A large electronics lab with 3D printers and the usual stuff. Enough equipment to build and test electronics and some mechanical things, including board assembly and stuff like that. We also have the real heart of the thing that what makes this lab special is the focus on testing facilities. We have a vacuum chamber, which we're adding thermal control to. We have a few other things I'll show you in particular. Here are some of the other sort of interesting spaces. It's a really cool place, and you should come and visit. We have more and more opportunities as we start to open back up. Just to some details, some of the things that we're doing right now. Number one is we're really trying to push and expand our thermal vacuum capability, which is basically like our space simulator, and we have this vacuum chamber that we've been using for some time now, and now we're adding thermal capabilities and other things. So we'll be able to support the more kinds of testing patterns that projects on campus and local companies might be able to take advantage of. The phase, I'll give an update on some of where this puts it in the big picture in a second. We also now have a vibration table. This is able to simulate launch environments on rockets, all the major rockets that are out there right now, and it's been acquired and installed. Everyone has been trained in how to use it, and it's now in regular use. This is capable of testing up to 6U CubeSats. 6U is about this big. And maybe even larger depending on the mass. We have a clean room, which will someday soon be rated. Isn't rated right now, but it's given the kind of protocols we're using. I imagine it's class 100,000 at least, if not better. It's one of the features is that it's quite small, so you're gonna have to cram in there to get a picture. But that means it's not used a whole lot, which is good. It keeps the counts down. We're building a pointing test bed. One of the things that we'd like to try to support is the development of pointing systems and things like that on campus and external. And this is something that not a lot of labs have. So we're putting a lot of development work into this. This is a sort of build project that the students are working on. And so here you can see this is a Helmholtz coil. These are two pairs. This is a pair of coils that simulate a magnetic field similar to Earth's magnetic field, and you put your device in there. And this is something you can buy off the shelf, but it's quite pricey, and it's also a really good learning project for the students. This is coming along at a nice pace. We also recently acquired a thermal chamber. This doesn't pull a vacuum, but can get quite hot, 175 C and down to -70 C. And it can use this sort of thing for lots of stuff like curing glues and cleaning parts, and you can even put a whole 3U Cubesat in there. This just arrived recently. New to us is this Anechoic Chamber, which is actually not in our lab, it's across the street. It's been around since the late 80s, operated by a professor who recently retired. And in collaboration with the Fulton School and with the EE department, we have access to this, and this is something we can use for things like beam mapping or other kinds of electromagnetic compatibility tests and things like that. It's a folded, if you're for the tech people in the room, it's a folded range. So that means we can get into the far field at up 2 gigahertz or above, which is pretty cool. And it's also got really great isolation at lower frequencies too. And it's also quite large. We still have the engineer that ran the place retired, but it is still available for training and stuff. So here's a rough schedule that we put together a few months ago to try to show where we were, or where we're going for some of these things I just told you about. We have a sort of stage development plan. We're pretty much right on schedule where we thought we'd be. We're sort of in the middle of phase, we call phase 2. It's kind of an arbitrary numbering. We're just starting that. So we have mostly these things to do still, but we're in the process of, for example, fabricating the thermal control first phase of the thermal control shroud for the vacuum system. So that's pretty good, and we're hoping to be through with that phase to be able to do hot control in the thermal vacuum chamber, hopefully by the end of the summer, and with cold to follow not long after. We're also supporting a number of projects that sort of to try to drive the development of these testing. You sort of need requirements. You need little projects that say what do you need. So some of the projects that we're currently supporting, one of them is DORA, which is a test of a laser comm system, which is supporting communications on around the moon, but also among phased arrays and things like that. And also, we're supporting educational projects like LightCube, which is aims to be a user operate any publicly operatable flashbulb that you can see with your eye. So I can give some quick updates on some of these things. First of all, we have a new project. We through the year, we've done a few other things, like we had our first in-person event. We had a little tour, and we also were awarded a launch for LightCube. So first, ExoCam, which is a new project. This is actually a project that was already at ASU. The goal is to drop a camera and have it land on the surface, and then during a landing event, so on the moon or on Mars or wherever. Normally, we just see the landing from up here, right? Or maybe from something way in orbit. The goal for ExoCam is to drop a camera and then actually see the lander landing from nearby. So this is a 360-degree camera, and it sort of lands on this beach ball-like thing that's see-through. The specific project here aims to do a test flight in August. And one of the things that we're doing for it is adding a plume detector. So when it lands, it's going to kick up a bunch of dust, and we're going to add a detector to that to try to characterize stuff that's being kicked up. So here's a prototype that was built by some of the students in the lab. It's basically some sensors that are stuck on the camera. Here it is over here, vibing on the vibe table. So even though it looks a little bit kludgy, it passes vibe. It should survive being dropped off a rocket. But this isn't the thing that's going to fly. This is just the first prototype. Here we are way back in February at our grand opening. Look at all the people in there. Here is the lunch that we had about a month ago. We had about 2 groups, small groups, come through and check out the lab. The goal was to introduce the lab to more potential collaborators at ASU, show off facilities, example projects, and discuss potential funding opportunities. So put together a list of how some of those projects I just told you about were funded. Furthermore, the team is a big team and constantly changing and growing. 2 of our members graduated, so we're wishing them the best and searching for their replacements. We're also searching for some more senior help, what we're calling a special projects engineer, to kind of help manage these projects and develop new opportunities. Specifically, so one of the things, and the last thing is this project LightCube, which was selected for a launch by NASA. NASA gives out free Cubesat launches to qualifying projects. This was selected a couple of months ago for an estimated launch date of mid next year. We'll be in orbit from 9 months to 2 years. We're not exactly sure. It will depend a lot on the space weather. There were some interesting reactions on the internet about the potential astronomy impact, which is not surprising considering that you're making light that's visible. This is kind of something of not exactly the point of the mission, but kind of not the point. So the goal of the project is to connect more people to space and to train students in how to make space hardware and then how to talk to it. So lots of people are going to go out and use this thing. And some other points to note here are listed here, but probably not. I don't have time to go into all the details, but you can go and check out our frequently asked questions page on the website there, or for some more details on the potential astronomy impact, which is very low because it's not flashing very often. And if you have more questions after that, there's our email address there. That's all I have to say.
Thank you, Danny. We have a couple of questions. Are there opportunities in this lab for a student with a geoscience background?
Sure, background doesn't matter. What matters is the lab is a makerspace type thing. So if you're interested in what the lab is doing and you want to get involved, then you can email us. And do I actually? The email address I will put in the chat, but it's just iilab@ASU.
And then a related question, do you need to attend ASU to be a part of this lab, or can someone apply to work in the lab?
You do not need to attend ASU to be involved. In fact, we have non-ASU people involved already. So just send us an email, iilab@asu.edu. And there's also, if you go on the website, interplanetary.asu.edu/lab, there's a click on students, there's an expression of interest form, which kind of collects a little bit more information if you're not sure what to put in the email. And I think answers the last question there. But the more the merrier, basically. And if we're looking, to solve specific engineering problems, but also for interesting projects. And I think that's where people that have other backgrounds can really come in.
All right, thanks. I'm not seeing any other questions. Oh, go ahead.
One last thing, sorry, Abigail.
You're fine.
There's a lot of other things to do here. So if you're interested, for example, in getting involved in writing or other kinds of media things, we get a lot of questions from the public. This project in particular, we'll be doing a lot of outreach and sort of talking and teaching, and so if you're interested in that sort of thing, then please come talk to us too.
All right. That means we are on to our project updates. And up first, we have the Earth Operations Center.
Yep. Hey, everyone. My name is Ashik. I am a media arts and science PhD student working with Robert Lee Kamwa in the School of Arts, Media and Engineering. And today I'm excited to present our project update on the Earth Operations Center. Give me a second while I share my screen. So yeah, I'm working on the Earth Operations Center. The team behind this project is Jake Pinholster, David Newman, Alex McDonald, and Robert Lee Kamwa. And I'm working on the virtual reality experience side of things, and I'm leading a team of students to develop this experience. And we are me, Luis Espinoza, Tatum Nebel, Joe Peterson, and Amanda Federico. So the Earth Operations Center is what we describe as a mission control for the climate. It's both a physical space, like a building that is currently being planned and designed, as well as a virtual reality experience for remote collaboration and informative storytelling. Specifically with the VR experience, we really want to capture the feeling of being in a collaborative scientific space that encourages evidence-driven discussion and different methods, evidence-driven discussions. And to facilitate that, we want to expose publicly available data sets and different methods of data representation. We're also working on using this experience as a presentation tool for convincing the right people in charge to take action on pressing climate issues. So this picture here is a sort of initial concept that Jake drew out back when he was envisioning this project. And yeah, so as far as current project updates, we have the initial VR prototype completed. We have a physically accurate model that people can walk around in VR that we plan to sort of use to inform the decisions for the actual physical building. We also have some initial connections to public NASA data sets, and we are able to display data in different forms, whether with 2D graphs or on a globe of the Earth. And after we completed that, we sent beta versions to testers and received feedback. This was a just really useful process. We sent it to people inside and outside ASU, both educators and scientists, and we got a lot of feedback on just the features of this virtual reality experience, but also on accessibility, how to make it easier for people to just be dropped into the experience for the first time and understand how to control themselves, how to operate it, what the purpose is, things like that. We also recently integrated a multi-user network space. Basically, we made it multiplayer. So you can now talk to other people and see them inside of the virtual reality space, and it immediately just makes it more compelling. It gives this real feeling of human connection inside of the scientific environment, which has been the vision from the very beginning. We've also been adding accessibility options, specifically for movement in VR, because it's still a new technology and lots of people are uncomfortable with specific types of player movement and things like that. So we're working hard to make sure that it's as accessible as possible. And we also are working on easier user onboarding. So our goal is that within being dropped into this experience, within 30 seconds, you are completely able to control yourself and understand how to navigate and interact with things. Because for the end product, we want to be able to just hand it to people and let them just experience it for themselves. Our beta version is on SideQuest, which is an unofficial Oculus Quest store, and we use that for dispersing our test builds. And we also have an App Lab submission pending, which is the official Oculus Quest store for most VR experiences. And this is just a quick recording that I shot earlier today. I apologize for the random mouse cursor on the screen. But yeah, so basically we had a tutorial room at the beginning that sort of onboards people into the experience and teaches them how to control the turning and the movement options, such as teleporting. This is the actual experience. We are modeling it sort of after a theater or mission control to give that sort of just majestic feeling, I guess, of everyone being around a sort of centerpiece. and being able to see the same data on the screen. So, and we also did synchronized data. So whenever you bring up, new data on the theater screen, other people in the experience would be able to see it too. And you can have discussions around the same thing that everyone is viewing from different headsets in completely different areas. And yeah. So challenges. Currently, one thing that we are trying to solve is finding open source data sets with public APIs. It's been surprisingly difficult. There are very good open source data sets that don't have easy to access public APIs that we can use to, pull the data and display it in the project. So that's something we're actively working on and having discussions about, and we appreciate any suggestions. We're also working on identifying more key personnel to participate in design discussions, because in the end, this end experience is for scientists. So we want to have scientists inform the design. Current obstacles, just increasing ambition and complexity. There's so much stuff to put in here that we're constantly tacking on new things, and we're able to do them, which is great. But it's just something that we obviously need to keep in check. Wins your opportunities. The implementation of multi-user collaboration was, I think, a very key implementation. Just it enables us to have real-time feedback and talk to people and discuss specific aspects of the project. And it also just makes a more collaborative experience instead of just having us develop on this separately. As for the future, we're working on just further technical polish, which is obviously an ongoing thing that will never really stop. But we do have a hard goal, which is that we need to meet the technical like hardware requirements of the Oculus App Lab submission. So hitting a target FPS, making sure that it's accessible and easy to use, things like that. And also we want to do more testing with newer versions of the project with the intent of increasing accessibility more and streamlining the experience so that we can give it to anyone of any age, any background, and let them experience it. We also are working on identifying those public dataset APIs, and Alex is currently seeking opportunities to demonstrate the experience to interested parties. And yeah, thank you for listening.
Thank you, Ashik. A couple of questions. Could you do a walkthrough in the virtual environment with an avatar to modify things with zoom in capabilities?
I'm not totally sure what zoom in capabilities mean, but yes, we are able to do a walkthrough of the environment and modify things. We have internal tools to modify the environment as we walk around inside of it. Yeah.
And then another question, what is the name of the application on SideQuest?
The application is called Earth Operations Center. I think we just recently made the application private on SideQuest just because we're working on a newer version with multiplayer. And with the addition of multiplayer comes the challenges of how do you limit which people can talk to you in multiplayer. So once we fix that problem and add some kind of authentication, we will be putting it back on SideQuest, and it'll be available under the name Earth Operations Center.
All right, thank you. Next up, we have Phil with 5 Senses in Space.
Cool, hi. Before I get started, I just want to shout out Ashik in that past project. I did some logistical works for Earth Operations Center, and most of the project was like Jake and Alex and Dava having a bunch of really giant ideas, and then Ashik and his team implementing and building and creating all of them. So Ashik did not shout himself out, but I am shouting you out, Ashik. You are awesome. Okay, let me do this. Cool, can you see that? Yes, great. So 5 Senses in Space. This is so cool. I'm so fun. This is fun. All right. So the summary of 5 senses in space, more or less, is to communicate Mars science through sparking imagination in novel story experiences. The different parts of that is communicating Mars science, using the imagination for the communication, and story experiences being the thing that sort of sparks the imagination. And the means of communication is multisensory, so using all these sorts of different senses: smell, touch, taste, listening, and embodying that knowledge. So in a way, it's making space knowledge embodied. Which brings us immediately to the challenges, which is COVID happened, and there was no embodied experience. When we eliminated embodied experience, there was no integration of multisensory tools. We were all on screens. We got visual, we got audio, but pretty much there's not very much to touch. We have this really big, wonderful trailer that is created into a Mars Hab that no one got the chance to enter because of COVID. There's no physical venues that we could host things. And of course, we're all like creatively fatigued. So much of the work is about using the imagination, and it's difficult to use the imagination when mostly what you're thinking about is like, how am I going to survive my next class that I need to teach in my next Zoom meeting? So it was challenging. It was a challenging year for the project. But these challenges helped us understand what are the things we value in the project. And what we value, what we were missing so much of, was in-person communal experiences around this idea of space. Hosting things online and in video just wasn't doing it. We value imaginative and educational storytelling, making the space multisensory and what it means to touch and feel and hear and smell space, and communicating science through story, not just through the idea of a fact, but what it is to embody the story of a fact as it exists in space. So we did a bunch of stuff. Even though there were all these challenges, we did stuff. One of the projects we're working on is the smell engine, where you can sort of give a user all sorts of different smells. There are user studies in progress and testing multiple odorants, and a workshop paper was accepted at CHI, which is Human Computing Conference, which is really awesome. There's also a planetary visor. We did a little bit of refinement on that, updated some user interface. We released all of the open source software so everyone can come on and play with this work. And Lauren presented at IEEE VR, which was a conference all in VR, which was like really, really cool. And mostly the work that I did was connected to Moria, which is this sort of imaginary mining company that exists on Mars in 2175-ish. So a lot of the work we did around this was growing a narrative around Moria and this company. We created this website. If you go there, you can see it. It is not polished, I promise you. But we created an imaginary website for the company. I did a lot of writing and recording to create Mars Public Radio, the radio that people are all listening to with various different stories about what it looks like, what different religions might look like on Mars, or the council and as they vote on the budget and different things. So we did a lot of imaginative writing. Some students came together and 3D printed a bunch of realistic tools, which will be part of our habitat. You can see the photo right there. Those are all 3D printed and created, these really cool tools. And over the summer, this student, Michael, is creating a whole Mars, like a mini Mars rover that he's doing. It's really cool. And we create a lot of videos for the HAB experience. Some of the things that we envision as we did this, a lot of the work that we also did was envisioning work. Because this year we created a lot of online content rather than physical content, because our physical experience work was really stymied because of COVID. We really envisioning tightening and sort of creating a better platform for all of our online content that we created around Moria. We envision relaunching the physical HAB. We really want to craft an interactive story in the HAB in sort of an escape the room style. You get to see, you're in there with all the bunks and all the research stations, and you can sort of be discovering and learning science knowledge through your interaction with this physical space. And because we also have Planetary Visor and Smell Engine, there is a whole lot of opportunity to create a holistic narrative within the hab. And one of the things that we are hoping, dreaming of, is pitching the hab to museums and traveling with it. It is a trailer, so it's easy to travel with. Well, easy. Ask Karen Valentine. It's easy to travel with. But to bring it around to different museums and actually launch that as a unified experience of a sensorial experience of Mars. And last, we're asking a bunch of big questions in this project. And some of the questions that we're asking, especially after this year, are how do we balance the physical and digital experiences? We have created a whole bunch of digital content this year. We are hoping to come back into the physical experience. What do we do with the digital experience? How do we mesh those two things together? We're wondering how to unify the elements of our project. Right now, we have projects that are based in different senses, but what would it look like for all of those to come together into a holistic experience? When can we relaunch the physical experience? We're like ready to invite people into this hab and touch things and smell things and be in there. This is sort of philosophical, but what does it mean to embody space knowledge? So much of the knowledge that we have around space is based in data, based in seeing things. What does it mean to put it into the embodied experience of an audience member, of a person, to feel as though they're in space, to feel as though they're in these particular things? And because our project is so much about storytelling, what are the stories about Mars that we want to tell? Storytelling, I come from the theater. Storytelling is extraordinarily powerful in creating futures. So how we choose the stories that we tell is the future that we will be creating. So how do we choose those things? That's what we're asking, 5 Senses in Space. Abigail, is anyone else asking anything?
Not at the moment, no.
Cool. That was fast, but it was really, really fun. We had a really great time working on this year. It was sad that we could not do any of the physical stuff that we wanted to, but we have big dreams. Big dreams.
Thank you, Phil. Yeah, I'm not seeing any questions coming in. So let's move on. Next up, we have Port of Mars. So Lance, whenever you're ready.
Hello, can you hear me?
Yes, we can. Yes.
Oh, awesome. Okay, so I'm Lance Garavi. I'm project lead for Port of Mars. Now, Port of Mars is researching what are called social dilemmas for communities in space and on Earth. So a social dilemma is a situation in which a whole community benefits if everyone makes certain choices. But those choices are difficult or they're costly, and so it discourages some people from acting in ways that will benefit the community. One type of social dilemma is called a commons dilemma. You probably heard of this, this idea was made famous by a guy named Garrett Hardin and his concept of the tragedy of the commons. So this is the space we're investigating here. Now, maybe to bring this, make it tangible, maybe you've worked at an office where there's a coffee fund, and there's that one employee who drinks a lot of coffee but never contributes to the fund. Or maybe you've had a roommate who never buys groceries or toilet paper. Maybe you've known someone during this COVID year who doesn't wear a mask or practice social distancing and has refused the vaccine. I don't know, maybe you're one of those people. Now, imagine that you're part of the first human community on Mars. All the resources that you have are shared communally, and they're extremely limited. And the stakes are really high because the environment you're in is deadly. There's 1,000 ways that planet could kill you and 1,000,000 unknowns. So now, imagine that your community includes the coffee fund freeloader and that roommate and the COVID resistor. How do you make sure that everyone functions effectively as a community? How do you ensure that things don't spiral out into social dysfunction? Well, the Port of Mars project started with this question: how can we best sustain healthy human communities in space? And we designed an experiment to find solutions. So Port of Mars is a social experiment, social science experiment disguised as a game. It's a game hiding inside, that hides a science experiment in its core. All right, so if you play this game, all the players are members of the first human community on Mars, and they're trying to get along and survive while isolated on this deadly, unpredictable world. The game is simultaneously competitive and cooperative. So players navigate a balance between pursuing their own personal goals and contributing to the good of the community. The player with the most points at the end of the game wins, but if the players don't cooperate and work together, the community collapses and everyone dies. And no one wins if everybody dies. So the researchers track player behavior. Then they analyze the data that they pull to discover or try to understand what makes a team succeed or failure. So each game is a kind of simulation, a sort of rehearsal for creating healthy human communities in space. All right, so our specific research question is, how can people effectively navigate social dilemmas and collective action problems under conditions of high uncertainty and high risk? Exactly the kind of situation that people will find themselves in when they go to Mars. But it's also describes situations we find ourselves in here on Earth. So we've got an amazing team. All sorts of disciplines have worked on Port of Mars. Here's a look at the core team as it exists today. Marco Jansen here is our lead social scientist. He designed the experiment at its core. He's one of the world's top experts on commons dilemmas. Michael Yi Chow designed the game around the experiment. He was the lead game designer. He works at Wizards of the Coast, the people that make Dungeons and Dragons and Magic the Gathering. I just want to share really quickly with you our milestones. So a digital game ready for an experiments complete. I'll describe some of these more later. The Mars Madness tournament complete. Utilizing exploration learning also complete, and sharing research with colleagues and stakeholders. So we first created Mars as a card game that you played on a tabletop, and we ran a pilot study in spring of 2019. And it was a successful pilot study, but we really wanted to work with larger sample sizes. So to enable that, and also to improve data collection, we spent a year creating a digital version of Port of Mars that people can play online. We completed the work on that in fall of 2020, and it works great. So in October, we ran our first experiments with the digital platform in our first ever Mars Madness tournament, which is like this NCAA type series of games in which players compete in a series of elimination brackets. Then in spring, we held another tournament. So our biggest challenge was actually recruiting students to play the game this year. It was surprisingly hard to get a lot of students to even just to come play a fun game. We've talked a lot, we've done a lot of postmortem analysis, trying to answer the question, why did we struggle so much to draw subjects for this? And I think we have some good solutions moving forward. I think some of it had to do with a very, very difficult year for a lot of ASU undergraduate students and a lot of fatigue. But that was, I think, clearly our biggest challenge. And we'll be making improvements and adjustments in the coming year to address that. Some of our deliverables. Well, we made a digital game. We made a computer game. Whoops. Let me go back. Yeah. So this is the interface for the game that players use to play. I'm really happy to report that not only does the platform produce useful data for us, it's also just really fun. Players are reporting what a good time they had playing the game. So the digital platform is one. Another, we published the results of our pilot study in the International Journal of the Commons. We look forward to publishing more results when we have more data. Then in January, Port of Mars was awarded a Decision Risk and Management Science grant from the National Science Foundation to further develop the platform. We were really happy about receiving this grant. We've applied for so many. This is a little bit of a weird project, and so it falls into the cracks between a lot of funding institutions. But we'll use the grant to help us scale up our work to handle larger sample sizes, to make the system more robust, to create machine learning tools to help us analyze and manage the data, and to launch some educational efforts to get the game into schools. So, like a lot of research in space exploration, the research we're doing will be useful on Earth as well. For instance, combating COVID-19 or climate change presents a host of difficulties like the ones that we're investigating. Now, with every game we play, the Port of Mars team is searching for ways to effectively meet challenges like those on Earth and in space, now and in the future. Because we're not just thinking about the future, we're rehearsing for it. So thank you. And I'll take questions. Looks like there are several.
I'm not seeing any on my end here.
Oh, I was looking in the chat. Okay, no questions. Okay, that's easy.
Yeah, let's see. Oh, we have a comment. Would love to see the Port of Mars team collaborating with 5 Senses. I think that data would be excellent to incorporate for lessons inside the museum hab.
Yeah, I think that's a terrific idea. I think there are ways, right now the Port of Mars game functions on a dashboard, but I'd love to see us develop more dynamic ways for players to interact in the game. Let's see, is there another one?
Oh yeah, I think there was
somebody made a joke about the coffee fund.
Yeah. Let's see. This naturally could be part of astronaut training. As this foundation grows, some of the findings or ideas could be used by the International Space Station.
Yeah, I mean, I'm not exactly sure that the game would be good for astronaut training per se. What I'm hoping is that the data and the findings that we collect from the experiments will that will be useful for planning missions and creating policies and procedures and best practices for future human space communities. Is there another one? I did the tutorial. You can play with AI players. Yeah, we have bots that you can play against. I don't think it's as interesting to play against bots because their behavior is really predictable, unlike people. Next question: have you taken into consideration the events that occurred at Pitcairn, where after 10 years, the mutineers were largely dead? 15 of the 6. I'm afraid I don't know that story. The print is really small. Can someone read that? I don't know what Pitcairn is.
I'm not sure what that is either, but yeah, it looks like Pitcairn.
Yeah, I'm sorry, I'm not familiar with that. I'd love to look into it. I mean, there's been all kinds of mutiny on the Bounty. Yeah. I think the question of mutiny is a little bit different than the challenge of the commons, which is what we're really investigating, rather than people overthrowing someone in power. How do people navigate situations where they're sharing resources and where there can be people that aren't contributing to the common good? Do you consider people who, for whatever reason, don't consider their own well-being, let alone the common well-being, like the homeless on Earth? It's a good question. What we find is, different people have different ways of approaching these dilemmas, obviously, and we're interested in gathering data from all kinds of people. It's one of the reasons I'm excited about the NSF grant, because it'll allow us to scale up the platform. So we can, so far we've only been experimenting with students at ASU. Undergraduate students are our subjects. But what we're looking forward to doing is moving outside of that demographic to experiment with other samples, other people, and other cultures that may respond differently to these kinds of dilemmas. A project like this is data hungry. We want input, and that's how we'll learn.
I think we just have one more comment. Yes, I think the results would be more useful for long duration human spaceflight.
Yeah, it's really about communities getting along and dealing with collective action problems and social dilemmas. Oh, okay. Unpacking the Pitcairn. Okay, great. Thank you.
Thanks. And I think you're up again for.
I am up again, aren't I? Okay, here we go. You get one more from me now. Let's see. Is my portable? Do I have the right thing up? Is it Mission Interplanetary?
Yes, it is.
All right. So I'm going to take you back several years. In Interplanetary Initiative's very first big question brainstorming session, one of the questions that was raised was, how do we galvanize public support for human space exploration? And over the years, this question has come up again and again. It's part of, I think, what inspired other pilot projects like 5 Senses in Space. And it came up again 2 years ago with the question, what sorts of public-facing activities could the initiative do to inspire and engage the public, to stimulate and excite decision makers? How do we get people involved in the big questions that II is asking and the challenges we're facing? Well, we need compelling narratives, like Phil was talking about. We need stories to power the mission of making us an interplanetary species. So how do we disseminate those stories? Well, as Lindy put it at the time, how do we socialize new ideas? Well, and I was like, hey, it's the 21st century. We should make a podcast. And everybody was like, hey, that's a great idea. So you should totally do it. And I'm like, what? So we started making a podcast. Now, the best thing I've done by far on this project was the first thing I did, which was assembling a team. And I don't mean to brag, but I kind of nailed it. This is our team. Our hosts are former NASA astronaut Katie Coleman, who is ASU's Global Explorer in Residence, best title ever, and scientist and author Andrew Maynard, who is also Associate Dean of the College of Global Futures. Both of these folks are brilliant, they're warm, they're just ridiculously charming, and all of their work is mastered behind the scenes by Steve Christensen, our immensely talented and veteran sound designer and engineer. Let's see. Here, just quickly, are our milestones. All of them are complete. I'll go into some more detail about those. So in the fall of 2020, we forged a partnership with Slate, the national media company, to collaborate on this podcast and produce a season of 8 episodes and 1 live broadcast event. And that was really exciting. We had to work for a long time to make this partnership happen, but we were successful. So a little bit about the character of the show. The podcast, much like II, is predicated on the observation that humans are becoming an interplanetary species. And you know, that may be humanity's greatest collective endeavor ever. What do we want that future to be like? So on Mission Interplanetary, we talk to experts who are imagining and designing and building that future. And in true Interplanetary Initiative fashion, Mission Interplanetary focuses on big questions for human space exploration, the challenges to overcome, the opportunities within reach, the mysteries to unravel. So our goal is to become a leading and accessible voice advancing the conversation on human space exploration, and to promote narratives of positive and inclusive human space futures. So in order to, one of our principles is, and again, this is something we draw from II, that in order to thrive in a new space age, we need to draw on the full range of human imagination, intellect, and skill. We need diverse peoples at the table. So Mission Interplanetary isn't just interviewing engineers and scientists, but also journalists and philosophers and lawyers and science fiction authors and museum directors. We're also deeply committed to creating a more just, inclusive, diverse, and equitable space future. Though the space sector is still very male-dominated, 7 of our 9 guests in season 1 were women. Because space should be for everyone. We're seeking to humanize space, to engage the public and spark imagination and bring space closer. We had a really, pardon the expression, stellar series of guests, including astrophysicist and best-selling author Katie Mack, former NASA astronaut Mark Brown, Smithsonian's Undersecretary for Science and Research, Ellen Stofan, and just a bunch of other people just who were all tremendous. Okay, challenge. This is kind of a funny story. So like a month before we launched, Slate asked us to change our name. We were just simply called Interplanetary, but turns out there was another podcast called the Interplanetary Podcast. They're not as cool as we are. They don't have Katie Coleman and Andrew Maynard or Steve Christensen, but Slate was worried that there would be some confusion. Well, we didn't want to change our name. The podcast was built around the concept that humans are becoming an interplanetary species and an inquiry into what that means. But I found a solution that we didn't have to give up that word interplanetary, so we became Mission Interplanetary, and that's what we are today. So deliverables. Here, some specific topics. So we produced a season of 8 episodes plus 1 live event featuring Jim Bell and Tanya Harrison talking about perseverance, which had just landed. And here's some of the topics of the various episodes. So I'll tell you, when I first conceived of this podcast, we set a goal for ourselves. We said by the end of the first season, we hope to be hitting, hold on your hats, 1,000 downloads per episode. I'm happy to say we exceeded those goals. We achieved a total of, as of I think yesterday, 61,000 total downloads, of over 7,500 downloads per episode, which puts us comfortably in the top 1% of all podcasts. Mission Interplanetary has listeners in 133 countries, and 20% of our listeners are from outside the US. I'll tell you, reviews have been extremely positive. Slate just loves the content we've made. We're excited about the stories we're telling, and we think we've made a really great first season. So we hope that you will listen and subscribe and encourage your friends and colleagues and family and networks and your dog and everybody else to subscribe. You can find us on Apple Podcasts, Spotify, Stitcher, or wherever you get your podcast. And as we say at the end of every episode, the future is interplanetary. We'll see you there.
Thanks, Lance. No questions, but there is a comment. This podcast was amazing and I want season 2 now.
Yeah, we're thank you. We're in talks about a season 2. So stay tuned and hopefully there'll be some news coming out about that soon.
Great.
I see there's another Port of Mars question. Has Port of Mars talked with citizen science? No, we haven't. But that's an interesting idea. One of the things I love about Port of Mars project is a lot of times with science, scientists do the science and then they engage the public and tell them about it afterwards. Port of Mars involves the public directly in the doing of the science and the solving of the problems. And I think that's really, and does it in a fun way. So, oh, Adam, thank you. Another fan of the podcast. Yay. Yeah, that's what I got.
All right, thank you.
Mm-hmm.
And last but definitely not least, we have e-learning in space.
Thank you. So first of all, how do I follow Lance? So I'm going to keep it short and sweet because I think that's probably the best thing to do at this point. But let me go ahead and share my screen. And I'm actually going to have us start on our website just to review what our goals were for this year. So first of all, I'm Mary Loader and I'm the project leader for the e-learning in space pilot project this last year. And our team was extremely diverse. And our goal was to explore what e-learning looks like in space. So what methodologies, resources, delivery systems, and technology would be advantageous. We kind of landed on formal and informal needs will need to be explored. And this topic is vast. So our stepping point was to first identify what communication needs do we need to address and what methodologies are available now and what can we be looking to explore in the future with students across ASU and anyone who wants to engage in this space alongside us. So I'm going to skip the milestones and just briefly review our team members. So our team was composed of Katie Coleman, former astronaut, Robert Lekamwa, talented director of the Meteor Lab at ASU, myself, Judy Lyon, who is a long-term Interplanetary Initiative participant and was key in our e-learning exploration activities, Joe O'Rourke, one of the faculty members out of CC, and Catherine Powell, who was not only beneficial towards our project as a teammate, but also wrote a script that we created a video around. I'll share with you briefly. We also have Bruce Bakey from the Solar Spell. He's the co-founder of Solar Spell, and it became an integral part of our storytelling experience and the live experience that we'll have in the future. Tina Sindwani and Patrick Rivers are our very talented student workers as a part of the project. Not only did they help me manage everything that was going on, but creatively created all of our slides over the last year and the stories that we're going to be unveiling. And then very key was from Solar Spell, Ashley and Priya made the 3D printed Solar Spell that's going to be in the Mars Hab in the future. So we thank the core team members, but we were also joined by creative consultants across the university. We were so lucky to have so many people interested in this topic alongside us. So now I'm going to share some of the deliverables. So feel free to get your cell phone out and scan these QR codes to explore as I go through it. It's going to be very brief and everything's available on our website as well. So feel free to take as much time as you need with these items. This video, Communication to Mars, was created not only by Catherine Powell, but also by a former student, Manira Batul. She did all of the original animations. So just very talented, kind of a fun experience. And we're going to be using this in some of our astronomy and planetary science degree program classes, and potentially some of our engineering courses over the next year to explore the kind of communication steps that we can contribute to at ASU. The next is Unearthing. Unearthing is an amazing experience that Patrick Rivers wrote through the collaboration of so many different explorative activities that took place throughout our team and Ed Finn's classroom, Prototyping Dreams. And it resulted in some very specific stories that were framed from Port of Mars and the character structure of Port of Mars. So the cast of characters that are listed here are mentioned throughout this memoir of Mars, the memoir from Mars, that were specifically written by Olympia Lebedev, who is Russian. So they're in Russian, but then translated for all of your reading pleasure. So you're welcome to go to the scientific team and read those stories, and you can also access them from our website. If you'd like to read more about the learning strategies and the characters and how they align with Bloom's taxonomy, I welcome you to also scan this QR code or access it on our website from Judy Lyon, where she not only defines the Benjamin Bloom's taxonomy and the level of cognition of each of the characters, but also aligns all of the different types of learning that are happening throughout the stories to the learning realms as defined by President Crow through ASU. And in the future, we hope to, and we will, have our memoirs from Mars as a part of the HAB experience on the solar spell that was created for the HAB in the 5 Senses in Space project. So that's a big part of what we've done this year. We look forward to the future where we can create additional learning experiences and explore additional needs of the social and formal and informal needs of learning on different planets in different spaces outside of Earth. And here's just that image of the prototype. It has been created, but it is not yet in the Mars HAB. So we encourage you to visit the Mars HAB over the next year and play with the solar spell and have a hands-on experience. And that is all. And so thank you all. And thank you to the team of e-learning. Feel free to visit our website, see the different projects and how they took place over the last year. And thanks again for this space, Lindy, and for being able to do fun things like this. And Abigail, for all of your help over the last year.
Thanks, Mary. No questions have popped up. So, Lindy, if you would like to share some closing remarks before we get on with our days.
Yes, I'm really appreciative for the team for presenting and all the amazing work that happened this year. It's despite the difficulty of this year, we've done a fantastic job of actually making progress, which is astonishing to me. And thanks to everybody who came today for our last quarterly of the year, our updates on our activities. I hope we all have a really great and peaceful and better summer than it was last year. And so much looking forward to seeing what happens over the summer with all of our projects and how we kick off again in the fall. So thanks again, everyone. And this will close our meeting for today.